Welcome to Vertical City. I'm your host, Lennon Richardson. During each episode, I interview one of the world's top experts in architecture, urban design, engineering, or ecology so that we can better understand and develop solutions for sustainable living. Thank you for listening, and get ready to join us on another groundbreaking and uplifting episode. Gregory Kiss is one of the world's leading authorities on photovoltaics and has advocated the practice of environmentally responsible architecture for over 30 years now. He received his undergraduate degree from Yale University and a Master's of Architecture from Columbia University. Upon graduation, he founded Kiss plus Cathcart Architects in 1983. He is also the founder of Native American Photovoltaics, which is a not-for-profit organization that brings solar power to the Navajo Reservation. His work and research have brought many advances to the solar industry, and he's been involved in numerous high-performance building projects around the world. More recently, Greg has developed an expertise in architecturally integrated food production. All right, Greg. Well, welcome to the Vertical City podcast. I'd like to start just by...
Lennon.
Yes, thank you. I'd like to start by asking you a few questions about the solar industry as a whole. I know you have over 3 decades of experience in photovoltaics, and I'm curious to know, has the rate of growth and change in the industry surprised you at all?
Well, the answer is yes. It depends, though, on in what way we're talking about growth and change. I think that the biggest pleasant surprise in the solar industry has been the faster than expected drop in prices, which has contributed to faster growth than expected. And compared with what we were all thinking 20 years ago or maybe even 10 years ago, we are well ahead of the game. And solar has become a major part of the world's energy infrastructure, ahead of schedule.
That's definitely good news. So looking forward to the next 30 years, what do you see happening in the industry?
Well, there's going to be different challenges, I think. The technology is not, I think, going to progress as fast as it has in terms of cost reduction and efficiency increase. That is a natural consequence, really, of the fact that these are asymptotic curves. If you plot the reduction in cost or increase of efficiency, these are processes that slow down as more and more progress is made, and that's natural. So I think that there will be some interesting improvements in efficiency. Efficiency and cost is linked, although not inextricably. Generally speaking, the more efficient you can make the panel, the lower cost it will become. So we are getting close to the peak efficiencies of certain basic photovoltaic technologies like crystalline or polycrystalline silicon. What I think we can look forward to is more progress in films, different kinds of thin films, and multi-junction devices where you have different kinds of materials deposited on top of each other, each of which can optimize a slightly different part of the solar spectrum and so on. So using those kind of techniques, there are theoretical peak efficiencies, which are much higher than what's available today, which is about low, mid 20%. Those theoretical peak efficiencies are actually well above that, perhaps 75% or more. But it will take a long time to get to those levels. And the resulting cost reductions will follow along. But we are already at the point where solar panels, in some cases, don't cost a whole lot more than the piece of glass that they're deposited on. So again, those are going to be certain limiting factors that will mean that the cost will continue to come down, but not as dramatically as in the past.
So you mentioned a few different types of solar that are available on the market. What are the most successful applications currently in practice, both the technology and where they're being implemented? Is it on rooftops, curtain walls?
Well, in terms of the basic technology, the clear winner, market leader at this point is crystalline and polycrystalline silicon. This is really the original solar technology. And frankly, that's something that surprises me a bit in terms of what we thought was going to happen 10 years or more ago. The reason for its continued tremendous success really has been the advent of the Far Eastern and Chinese solar industry with their economies of scale and so on, has meant that that type of technology has become very inexpensive.
I see.
The thin films, I think, still have a long way to go, further to go in terms of improvements, and perhaps have not been invested in and focused on as much as the crystalline type technologies in recent years. In terms of how and where these solar technologies are being used, other than standalone
Solar
power
farms,
arrays in the desert or what have you, which there are plenty of. What is of interest to us, urbanists, planners, architects, and so on, is really how these technologies can be integrated into our infrastructure, our buildings, and so on. So I would say that still the fairly straightforward rooftop applications are by far the most common and economical in terms of urban and building applications. It has been, again, not as much of a surprise, but a bit of a disappointment to me that what I would call the true building integrated applications have not progressed faster than they have. And the issue there is, and this is where we're talking about using a solar material as an architectural or constructional part of a building, part of the building skin, part of the skylight, a shade device, something that you would want and you would build anyway.
Right.
And if you, in that sort of application, you get the benefits of the BIPV credit. That is, since you're replacing a conventional material you would have paid for anyway, you save that much money. And certainly in terms of facade materials and so on, there are plenty of facade materials we use today that cost more than certain photovoltaic panels do. So you can imagine in a case like that the net cost to do a solar versus a non-solar building facade, let's say, could be very low. It could actually be cheaper in some cases. Mm-hmm. So in that case, there is that wonderful kind of goal of BIPV really, which is low cost, very low cost, or even essentially free renewable energy. And but as I said, it's we haven't seen much of it yet. I still think the main reason is that the industry continues to focus on selling standardized products for remote farms, for rooftop arrays, that kind of thing. Those standard products are not well suited to integrate into building envelopes. What we need to do building envelopes, to do BIPV really successfully, is an industry that can produce these PV devices in an entirely customizable way. It basically that produces PV materials in the same way that the current building industry produces conventional building materials, so that you can order, any number of square feet of a photovoltaic panel in up to some limit in any size and shape and color that you want. So that type of customizability has not yet been achieved in terms of the main players of the solar industry. There are plenty of kind of second-level customizers that are doing that, but because of the fact that they are an additional step in the production chain, it means that the cost of doing that kind of customization can still be very high.
So if I'm hearing you correctly, you think that the major issues lying with the providers of these technologies themselves and not with the architects that are trying to implement them, that needs to be made easier so that architects can easily work these technologies into the buildings without having to change their designs to fit the existing technology.
Yes, I think that's the number one issue, but there are a lot of issues that overlap with each other and maybe reinforce each other in some ways. I think it is still true that most architects, engineers, and so on are not aware of what the real potential is of BIPV. There are still issues with codes. There are issues with insurance, I suppose, with the sort of the many levels of familiarity and acceptance that the building industry, which is inherently a very conservative industry, needs in order to really embrace a new type of product on a large scale.
So what do you think it takes for that to happen in the industry? Does there just need to be a strong leader who's educating the population and providing products that work for the types of architecture that's being developed?
Well, yeah, it's turned out to be, this has been a difficult question for a long time now, and I can't say that the answer has really become any clearer over time. I've always felt that there's probably a critical mass of a couple things, and the number one issue still, I think, is going to be the product and manufacturers, like the real OEM manufacturers who make the photovoltaic panel in the first place, getting into this customizable mode, because I think that is what is going to be necessary for there not to be a significant cost premium of delivering customizable product.
Sure.
Now, on the other end, I imagine that probably some number of inspiring, exemplary projects could really inspire people, could inspire building owners, designers, and so on to go down this road. Some degree of standardization and rationalization of code issues, insurance issues, and that kind of thing would be very helpful as well. And maybe as well a new generation of designers who I think are really looking for inspiration in ways that will allow their projects to be really environmentally positive.
Are there any particular projects that either you're working on or that you've heard about that are particularly exciting that might help to grow this technology and make it more popular?
Well, that's a kind of a difficult one. In my own experience, in an odd way, in certain ways, I feel like we've almost moved backwards in the last couple decades. And that's because early projects we did in BIPV, we were really enough ahead of the industry that nobody was expecting this type of application. And so what that meant was there was a little bit more freedom in a sense to do some of this stuff. So early on, we had projects where we were lucky to be able to get customized PV. We were lucky to find intelligent, enlightened building officials who were comfortable approving these applications and so on. And so since then, though, the industry in some ways has sort of ossified a little bit because there is now some more awareness of the existence of photovoltaics and the fact that they can be integrated into buildings. And to some degree, I think that's caused building officials to maybe become a little bit more cautious, actually. So because of that and because of the continued lack of truly customizable products, I don't think there's been anything really fundamentally new and inspiring in BIPV in recent years. There are projects going up, and there are big ones and beautiful ones, but I would say that what is inspiring me more today is something else. Like at the moment, I'm in New York City, and like many other big cities in the developed world, we have here amongst other issues, we have a big crisis of affordable housing, let's say, right? So this is something that there's a push on to remedy or to mitigate by constructing more affordable units. And one thing that's really interested me in recent years as we've worked on some of these projects is that, and this is not a project type affordable housing that you would think of as a kind of glamorous, high-end sort of building type. But what we have found is that developers, city officials, really the sort of most influential players in this area have become not just accepting of many advanced technologies, but in some cases really asking for them or pushing them. And by this, I mean not just photovoltaics, which has become, to many developers, a very standard part of their palette of features in a building. So I'm aware of a number of developers who really expect to put as much PV as they comfortably can on the roof of their building.
Mm-hmm.
In tandem with that, other very interesting developments like the rising popularity and acceptance of passive house has been really interesting to me. So the fact that passive house, which is a standard to make very efficient building envelopes, basically, that use much less energy for heating and cooling, has caught on. It's becoming accepted. And what that does is it kind of works really beautifully and appropriately in tandem with photovoltaics and renewable energy generation, because going back 30 years, many of us were always aware of this notion that it wasn't really appropriate to be integrating PV into a building project where the building itself is highly inefficient.
Mm-hmm.
And the amount of energy wasted by an inefficient building, certainly back then and still today, is very likely many times as much energy as you're going to be getting from doing PV. Well, that's really what's changing. And it's getting to the point now where through not just passive house, but a number of standards, environmental initiatives, codes, and so on, that the buildings potentially are becoming radically more efficient with much less energy consumption. And we're getting to the point where, very interestingly, in New York City climate, let's say, just from the rooftop area of a multi-story building, you can already generate enough energy for, say, 2 or maybe more, 2-3 stories of building below it. And as these trends continue, as building efficiencies continue to go up and therefore consumption goes down, and as solar becomes more efficient, we are really now looking at the prospect of being able to power relatively tall buildings, realistically, even in an urban environment where there's a lot of shadowing and so on, and there may not be a lot of vertical surface that has good exposure to sunshine, that buildings of that sort actually could be on a net basis zero energy, or perhaps producing more energy than they consume. So there's something really exciting about that this sort of parallel trends of increasing efficiency with reduced cost of generation, so reducing consumption, and now being able to generate clean energy at the same time, is coming into a certain kind of a balance, which feels for the first time really sustainable in many ways.
That's definitely very exciting. So in our book, we interviewed you for a couple years back. You talked about zero impact buildings, and that you believe that in the future that this is going to be the standard, and that more and more architecture will be what you call productive architecture. I'm just curious to know how you're feeling about those statements now, a couple of years later, and how close are we to potentially seeing a zero impact standard?
Well, I think we are moving in that direction. There are rating systems and standards. LEED is moving forward. Living buildings standard is much more aggressive in that sense and sort of approaches this kind of idea. There are places where passive house has become code required, actually, in certain cities. In Europe, for example, it is actually required. So, and then there is, in parallel with that, there is the surprising evolution of the solar industry with its reduced costs and so on. So we are getting closer. I'm not aware of any place that has enacted a standard that it truly is at or close to zero impact, but it's definitely moving in that direction. And there's a lot of interesting challenges, I think, that go along with this, that are going to perhaps complicate that goal in some ways. As renewables and solar in particular become more and more popular and a larger percentage of our energy mix, there are significant challenges that have been introduced in terms of balancing the demand with the supply from the sun and the adoption of storage storage in individual buildings or in neighborhoods or cities or what have you, or demand-side management to manage those discrepancies between supply and demand. So as we get closer, as all of these things, increased efficiency and increased use of renewables, as those trends continue, there are kind of new complications that I think we didn't necessarily think much about 10 years ago or so in terms of getting to this kind of productive infrastructure standard. But I do think these are all problems that can be solved and are going to lead to probably some very interesting solutions, technologies, and products along the way.
So the solar that's being integrated today is still predominantly opaque, or maybe you could say translucent. But I know I've heard about solar window technology and that's accessible. But I'm curious if that's viable and if you think it will be something that we see commonplace in the future.
No, I think we will, but I don't think there is a true viable solar window product available today. And the reason for that is that, windows there's a very high standard to what we will consider an acceptable window. And this is something that we just take for granted, that a piece of glass is a piece of glass. You look through it, you see perfectly the quality of the light and view through a window is perfect. I mean, it might be tinted to some degree for comfort or what have you, but still, we want to see through the window and we want to see our view perfectly. The photovoltaics compete with that because, of course, any light that is passing through a window, reaching our eyes, is light that is not being converted to electricity. So there are different ways people have tried to address that problem. I mean, it seems to me that the ideal solution would be some kind of a magical technology that that lets through just exactly as part of the spectrum that you want minimally to get through to give you a good view of the outside world, and then converts everything else into electricity.
Yeah.
But I don't think that there is any such material that does that automatically and inherently. So there are ways people have tried to get around that by taking what would normally be an opaque photovoltaic material and patterning it. You can burn, say, a very fine dot screen into an opaque material, and when you're far enough away, it will seem to be transparent. But that tends to come with a big penalty in efficiency and cost, lowered efficiency, increased cost, and also usually, as far as I know, I don't think I've ever seen that type of product where the specular visual quality is perfect, is as good as it is through a piece of conventional glass. There's other methods people have used, like using holographic films on the glass to bend some of the light to the edge of the piece of glass where there's a solar collector, or prisms that do similar things. But again, those are all, they may work, but the biggest problem to my eyes that I've seen so far has been that those types of techniques tend to more significantly compromise the view quality through a window. Now, having said that, it is not certainly not necessary that all of our window glass be perfect vision glass in that way, because if you have an office or a home or some kind of public space where you might have a big window wall, and it may be that you really only care about the view through a relatively narrow slice of that wall, like looking out at the horizon in the distance, and that there's a lot of glass above and maybe below where you're seeing sky or you're just seeing field or something, where the quality of the specular view isn't as important. So I think that there is a lot of room for solar window products that don't necessarily work as a picture window, but will work quite well in as transparent or semi-transparent facades.
All right. Well, I'm going to move our conversation along to a new topic, that being food production integrated into architecture. But before I do, I just want to see if you have any final comments you want to make about the PV industry before we transition.
Well, it's just a really interesting time. The industry has matured. It has taken its place as one of the major players in the global energy mix, which is really the biggest and in some ways the most important industry in the world. And so it's grown up and it's confronting now a new set of challenges in terms of cost, integration into the distribution system, and so on. So it's going to be a really interesting time to see how well and smoothly and economically that process continues.
Yeah, I agree. It is definitely very interesting, and I'm looking forward to seeing what happens in the next 10 or so years. It's going to be quite interesting. So now moving on to our next topic, which is architecturally integrated food production. I know that this is something else that you're very passionate about and that you have some expertise in. Why do you feel that it's so important that we really integrate our food production into our architecture?
Well, there's a lot of reasons, really. And producing food reliably, efficiently, cleanly is one of the most basic human needs, certainly. Mm-hmm. And so the benefits of producing certainly fresh produce without pesticides locally, without a lot of transportation, those benefits are really very large and are pretty well known, I think, now to a lot of people. But there are other benefits which I think are in many ways more important. I mean, the urban agriculture movement is growing quite well, and having large hydroponic greenhouses on the roof of food stores or shopping centers and that kind of thing has been shown to be a very viable business and something that is really attractive to people, and with all of the health and environmental benefits that I mentioned. So I think that process will certainly continue. But there's a sort of second level or second type of application and benefit to integrating food production, which involves psychological, maybe mental health benefits in addition to the physical health and energy and environmental benefits of this type of food production. And that is that just being in the presence of nature, being able to see where your food comes from, having green leaves in your vicinity have a lot of value. And there's been plenty of studies that document this. It is inherently a somewhat fuzzier metric than many others that we try to pursue, but there is certainly by now an understanding that living in the presence of nature, vegetation, and so on increases your sense of well-being. It decreases illness issues. It decreases absenteeism in offices. It improves performances in schools. It improves sales in commercial environments. And so those sorts of benefits are a little harder to measure, but are, I think, potentially orders of magnitude more valuable than actually just the value of the food itself. Huh. So particularly in many parts of the world where there is many of the fastest parts of the world right now are in places where people perhaps shouldn't even be in the first place, but places where there's not a lot of water, there's not a lot of natural greenery and so on, that in those kind of places, the benefits to human health and happiness are particularly strong because you don't have natural green that like you do in places like here in New York City. You know, we're very lucky that way. So there is that kind of extra, very important benefit that I think is still to be had. Okay. So one of the projects that you worked on was a concept for rotating gardens, which I think is really quite interesting. And I would like for you just to take a moment to explain this concept and how it works and what are some of the benefits. Oh, well, the rotating garden. Well, I guess what you're talking about is an idea that we had some time ago now, some years ago, in which we developed really originally for a Buckminster Fuller Institute institute competition in conjunction with a group called New York Sunworks here in New York that work with Arab engineers and so on. And this was taking what is really a very familiar technology today of the hydroponic industry, which is called NFT systems, which is a nutrient film technique, meaning that you have these plastic trays that have a very thin layer of water running at the bottom, and that water has just the right mix of nutrients in it, and you have whatever type of produce that you need growing in those with the roots just sitting in that water. So they're getting water and nutrients extremely efficiently. And so basically these things look like normally long rows of plastic trays arranged in horizontal tables, essentially, in greenhouses. And we thought that technology could be adapted to be used in vertical applications for buildings in urban areas where you may not have much roof area, you may not have potential to do the kind of horizontal greenhouse most of us think of when we think of greenhouses. And so basically by putting these NFT trays onto a device that can raise and lower them, or actually kind of rotate them around like a big vertical carousel, and putting that in a double skin facade on the building, you get a very interesting set of benefits. And, we're always looking in any kind of new application of a technology or a building-related system for multiple benefits. That always seems to me to be the sign that you're doing something right. That is, if you're solving one problem and you find in the process of doing that you're also solving another problem, then somehow that tells you you're on the right track. And so here, certainly you can adapt this NFT type system. And our idea really originally was that you could even have a 10-story high, let's say, version of this NFT system where the series of trays are rotating slowly around like a Ferris wheel almost. And it takes about a month for them to make that trip, so that you can do all your work at the bottom of this rotating assembly of NFT systems, so that you plant a small lettuce, let's say, and then by the time it's made its way around and back down on the backside, it is fully grown. So you can harvest the grown produce and plant a new one all from the bottom of this device that's in your double skin facade. So that seemed like a kind of elegant way to take care of the servicing problem. But then we were looking for other benefits, as I said. And so you can imagine that this device behaves in a way like a solar control device. In a way, it's a bit like a giant Venetian blind. And because of the fact that it moves, you can control the angle between the rows of these trays and can control the amount of light that is passing through the double skin facade of the building and into the building itself. So not only are you growing produce, but you're controlling daylight in the building behind it. And really, we don't want much direct daylight to come into our building. We want as much of it as possible to be converted into biomass in our NFT system. And beyond that, there are even other potential benefits that thermal benefits, let's say, that in hot weather, there is a certain amount of evaporative cooling effect that you get from all these plants with the water circulating through them. So you actually might be able to introduce slightly passively cooled air into your building. There is also of course, the very basic exchange of carbon dioxide and oxygen that underpins nature, so that the exhaust air from buildings, and now as we have more and more efficient passive house type buildings, let's say with energy recovery ventilation, the ventilation stream has become much more controllable. And so exhaust air from buildings is very rich in carbon dioxide, which is what we all exhale, of course.
Right. And
that's exactly what plants need to grow. And growers introduce carbon dioxide into greenhouses to speed up growing. So by doing that, just kind of automatically, our exhaust air from the building is improving, is speeding up the growth of the plants, and then we can take air into the building from the other end of the system, which has been oxygenated by the plant. So there is basically that very basic aspect of nature's carbon cycle that you can capture in a building. And now that, as I said, with the advent of increased use of tightly sealed buildings with energy recovery, ventilation, and so on, that type of exchange has become more effective and easier to accomplish.
So is this a technology that you would see integrated in around the facade of the building, crossing over the roof, or would it be something that's basically pinned to the side of a building?
Well, it could be done in any number of ways. It could be vertical on any facade that gets enough sun. It could be rooftop. It could be in some kind of freeform building as well, where it kind of continues up and over and around different parts of the building. It's something that is, I think, really very flexible potentially and limited by your ingenuity, and although I guess most basically limited by the solar access. So where there is enough sun, you might want to do it, or you might want to consider doing it. And where there isn't, then you don't. So, this is perhaps another way that environmentally responsive architecture will have some new expressions. I think that we are we've been used to designing buildings with little or no regard to the environmental inputs into them, sun, wind, and so on. But I think once you start to do things like the IPV, or you start to introduce building integrated agriculture, you really have to think about these things, and hopefully those considerations will provide inspiration for more interesting and appropriate and thoughtful architecture.
Yeah, this is really interesting to me. I think it would be interesting to see this, and I'm kind of imagining myself working out of an office, and instead of staring out my window at a McDonald's billboard sign every day, I'm seeing fresh grown lettuce, and I'm kind of just imagining the health benefits that might create for a society.
Oh, absolutely.
Yeah.
Sure. Or strawberries, or kale, or any number of things. Sure.
So I'm curious whether you think this sort of concept, either maybe a rotating garden or a hanging garden, how does that compare against these indoor vertical farms that we're now seeing produced? And do you think that one is better than the other, or maybe a combination of both?
Well, there's there's different types of indoor farming that are being developed these days, and lots of different ways to do it. Probably the most basic issue, I think, that determines how one goes about this is the degree to which you are relying on artificial light. And that, I think, is a really interesting question. I mean, if you first look at this issue, it seems like, or certainly seemed to me, that it doesn't make a lot of sense to rely only on artificial light, let's say, like growing indoors, completely indoors, or on the ground or something like this, because to get artificial light, you need an energy source. And if you want to be clean and renewable about it, it's going to be, let's say, solar energy, photovoltaics. So a photovoltaic panel is going to convert at this point at most, going to be up to 25% of the sun's energy into electricity, and then that electricity is going to go to an LED. Even a highly optimized one is only going to convert a fraction of that electrical energy into light. So by the time you've gone through these two or more conversions of energy from light to electricity back to light again, it's a pretty inefficient process. So it just felt initially to me like, well, that just doesn't make sense, and let's look at ways to directly use the sunlight for our agriculture. And I still think that's true. But having said that, there has been a lot of very interesting technological developments along these lines. LED lighting is really a critical component of this. It's something, a technology that was not widely available until recently, still is coming down in price. And at the same time, is able to be optimized in terms of the spectrum, the wavelength of light that they emit, which can be tuned quite finely and increasingly finely to the needs of the plant. And this is a very interesting and complicated topic as well, in which plants may need different types and quantities and periods of light at different stages of their development and so on. So in the end, it actually may work pretty well to do indoor growing with artificial light. And, there's a lot of different, considerations. But one thing is that certainly in cities, there you are limited in the amount of exposed surfaces that have good sunlight. So you don't have that issue when you're growing indoors. You can grow a great deal of produce in a very, very dense environment if you're doing that, and there's more control over it and so on. So the issue of controllability, food security, and so on is really very important. That is a benefit generally of controlled environment agriculture, which includes greenhouses. But in a sense, you're increasing your level of control and your level of reliability and so on by going indoors. So I think there is certainly a future for that type of farming. I can't pretend that I know how much of the market will go that way in the long run, but I think it will be a part of our food future. But having said all that, again, as an architect, that type of technology is not as interesting to me, because it's something that has very little architectural significance, really, because you're growing plants indoors. They could be underground. They probably are better off underground, really, because you can use the above ground space for other functions. And so it doesn't have the kind of design, doesn't present the kind of design challenge that it does to grow plants in sunlight, where they are, by definition, part of the exterior envelope of the building, part of that interesting ecotone, if you will, between the interior human environments and the exterior natural or urban environment.
How long have you been working on these ideas of integrating agriculture into architecture?
Well, let's see, a fairly long time. I think that in our case, it was what in retrospect seems like a natural or inevitable progression from having been lucky enough to be involved in photovoltaics back in the early 80s, when it was a very new topic, certainly in terms of building integration. That early work in BIPV sensitized us. I know certainly to me that struggling with ways to integrate this solar technology into material and so on, it sensitizes you to, well, where is the sun coming from, and how does it relate to your building and to this energy generating surface and so on. And that then kind of by extension, you think about other things. Well, what about you want to be capturing as much sun as possible on the solar device, but at the same time, that device is potentially shading something. You may want sun or you may not want sun. So you think about light, you think about shade, you then think about you think about wind, you think about ventilation, you think about other natural forces on your building envelope, rainwater. What do we do about that? And how can we integrate as many environmental inputs as possible into our buildings in ways that make sense functionally, economically, and architecturally, and so on. And so that kind of thought process leads you to plants as in a way, as just another dynamic solar device. Mm-hmm. And so we originally began thinking about ways to have kind of plants as active architectural elements, as seasonal shading devices, let's say, or as ways to filter air, improve air quality, that kind of thing. And, one example is a project that, interestingly, only now is under construction, will be finished in the next few months, Bronx River House, but that we started designing almost 10 years ago, in which we proposed a multi-layer living facade that would have similar function to a forest canopy. Working with biologists, you can see that in an old growth forest on a hot summer day, you can walk in and the temperature is, and the environment is very, very different than it is outside in the forest. It can be actually significantly cooler than ambient temperature. So it's not just shading that's going on. There's a whole complicated series of events happening, from upper level leaves to mid-level leaves to lower level ferns and mosses and so on. Mm-hmm. And all that is producing a really beneficial kind of microclimate. So in this project on River House, we looked at ways how can we take the kind of horizontal layering of the forest and turn it on its side and wrap it around a building and use those effects to create a favorable microclimate, mainly in the summer because we want to cool the building, we want to use less air conditioning, but we also want to filter the air, improve the air quality, and then in winter, this becomes a kind of dynamic solar control device because we have leaves that deciduous vines where the leaves fall down and so on. So it was that was sort of the first step into kind of really a serious and active integration of biological processes into architecture. And then, once you start thinking that way, growing food is just kind of the ultimate application of integrating vegetation into a building. So sure. That's sort of how it came about.
In the future, do you think we're going to see lots of living green buildings?
Yeah, I do. Again, these are technologies that need to mature. I mean, these are not as high tech issues as we have in the world of solar energy, let's say, but there will be more and more products developed that do this, that from the mechanical aspects of if it's going to be, let's say, some kind of hydroponic system that works vertically, to equally significant or maybe more significant, I think, is control systems, intelligent systems to monitor plant growth, deliver nutrients, deliver light spectrum at the right time, and so on, so that you don't need to have a farmers or agricultural specialists on building staff. There's, I think, that kind of intelligent control is something that we're seeing everywhere. Of course, cars are now actually much more complicated computers than anything else we have in our lives, including buildings. It's kind of too bad and will change, I think. And so, I think we'll see that type of intelligent control will enable, along with the ultimately simpler, I suppose, mechanical engineering advances that will make these kind of building integrated systems reliable and economical and so on, and even maybe enable systems like a refrigerator that you can have in your kitchen that is a self-contained hydroponic growing system that allows you to supply your own lettuce in your kitchen. So there's a whole range of products and applications that I'm looking forward to, hopefully sooner than later.
Yeah, absolutely. All right, well, we just have a few minutes left here, so I'm curious if you have any parting words or advice or maybe even a call to action you'd like to make to our listeners regarding photovoltaics or the agriculture integrated into architecture.
Well, we've come a long way down these roads. We've come a long way on the road toward a truly sustainable urban or built environment, let's say. We are certainly not there yet. We have a long way to go. One of the biggest barriers or issues in moving this process along that we haven't really talked about yet, though, is awareness and aspiration on the part of anyone who's involved in a building project. So if people who matter in developing our buildings and cities, from politicians, planners, developers, to engineers and architects, as they become more aware of what the potential is in all these areas, I think that should promote a higher level of aspiration. I mean, that's one thing that I think personally I've always found has been critical to any successes that I've had in terms of architecture, and that is trying to do the best possible project, trying to understand what the technological, economic, regulatory limitations are, and to get to the very best result you possibly can, which is a very different mindset from the way a lot of the, let's say, the green building movement works traditionally, which is to look at business as usual and try to improve on it, try to do things a little bit better than they have been done. I think what we really would benefit, all of us would benefit from, is kind of flipping around that mindset. Don't spend your time trying to improve on current practice, making things a little bit less difficult or bad. Try to do the best that is absolutely possible. And, that's something that we will never quite achieve, but we'll get closer and closer to it as time passes.
Thank you very much. I appreciate it, Greg. This has been an excellent interview.
Okay, great. Thank you.
Thank you for listening to this episode of Vertical City. Learn more about the Vertical City concept and continue the conversation by visiting our website, verticalcity.org. I truly hope that you have enjoyed this episode. If you did, please subscribe to our podcast, leave a review on iTunes, and most importantly, share Vertical City with your friends and colleagues so that together we can create solutions for sustainable living. I'm Lennon Richardson, signing off for the Vertical City team. See you next time.